30, I'm just going to do letter B. So 10-30 says examine each series below and write expressions for the nth term. So they have this series for odd numbers, and then it goes 1, 3, 5, 7, dot, 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 and then you have written this expression. And then same thing with the even numbers, it goes 2, 4, 6, dot, 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 and then you write this expression for it, because it's adding 2 each time. But then in letter B, it wants the sum of each series. And we know that we can sum up an arithmetic series by like adding the first plus the last. Because if this is like 1, 3, 5, 7, 9, it's skipping by 2. So this would be 149. This would be 147. 145. If I wanted to fill in more numbers here, and every time I add these up, they make a pair, and the pair is always going to add to 150. So see how the first one plus the last one adds to 150? And then 3 plus 147, that's also 150. 5 plus 145 is 150. This whole string of numbers, if I were to write them all out without the dot, 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 it would give me a bunch of pairs of 150. So that's where this formula comes from, and this is the one that I always show you when I'm wearing my little formula hat. It's the one that we talked about with the rectangles, and you would stack the taller rectangles on the shorter rectangles with the histogram, and some people were thinking about this as a trapezoid. This is our formula for the sum of an arithmetic series. So all we need to be able to sum up either one of these arithmetic series is we need to know what the first term is and what the last term is and how many terms there are. Well, we have the first term and we have the last term. What we don't have is how many terms there are. So all you have to do to find out how many terms there are is plug in 149 right here and solve for n. And I already did that. I just plugged in 149 for the t of n, and I solved for n. So I subtracted 1 on both sides, then I divided both sides by 2, and then I added 1 to both sides, and I found out there's 75 terms. So now I can use my formula. So n over 2, so now I know it's going to be 75 over 2 because I had to do this little calculation here. And then I need the first term plus the last term. Well, the first term is 1 and the last term is 149. Okay, and so then I know that's n over 2 times the first plus the last. 149 plus 1 is 150, and multiply that by 75 over 2, and you get 5,625. So I'm going to do this one. So I'm wanting to put this into my formula. So I know it's n over 2 times the first term, which is 2, plus the last term, which is 150. But I don't know what n is. So how can I find out what n is? Well, I can plug in, I know that the last term is the nth term, and I can plug that in right here. So t of n, let's do it right here. When t of n is 150, what's n equal to? So I have to find out. Oh, what am I doing? 150 equals 2 plus 2 times. There we go. Okay, so I'm just using this formula, and I'm plugging in for n, or for t of n, I'm plugging in 150 right here, and I'm going to solve for n. So I can subtract 2 on both sides, and that would give me 148 equals 2 times n minus 1. 148 divided by 2, I can do that in my head because half of 14 is 7 and half of 8 is 4. And that's n minus 1. And then I add 1 to both sides, and n equals 75. Hey, I should have known that. What? have to do all that hard work. I should know it's counting by twos. And it goes to 150. So, but anyway, n is 75. So all I have to do is plug 75 in for n. Okay, and then I'll just put it in my calculator. I think I messed up. 75 divided by 2 times 152. There we go. 5,700.